pi there. So in this video, we'll be tackling again the parabola, but this time let's try out some more challenging examples. So without further ado, let's begin. We recall from the previous video that we learned what a parabola is. So a parabola is the set of all points that are equidistant from a fixed line D, this one, which we call the directrix, and a fixed point F, which we call the focus, this one out here, that is not on the fixed line. In this illustration, the parabola is this curve out here. So you can check that if you obtain a point out here, its distance here must be equal. Out here, these two must be equal, and so on. So aside from this, we also learned some more details that are important in parabola. The first being is the line passing through the focus perpendicular to the directrix. We call this the axis of symmetry. It would be this red line out here. We also learned the point of intersection of the axis of symmetry with the parabola, which we call the vertex. So it is this blue point out here, which we usually denote by V. And then lastly, we learned that the line segment through the focus with endpoints on the parabola and parallel to the directrix is called the latus rectum. It would be this orange line out here. Afterwards, we also learned the equation of the parabola. In terms of a equation, we have two types of equation of a parabola. One being the squared variable is the x variable, and the other is when the squared variable is the y variable. So the difference is that this one, since the squared variable is x, you expect that there will be 2x in y value. So the parabola must be oriented vertically like this or like this. On the other hand, for this case, since we have squared y variable, this means that you can expect that 2 y values in one x value. So the parabola will be oriented horizontally like this or like this. Also take note that the P here plays a role in how we obtain the focus and the directrix, as you can see out here. But then again, like I mentioned before, I don't really recommend memorizing the formulas for focus and directrix. It's a matter of understanding how it works instead. This last column, the orientation, I suggest that you master this one. So just remember that when P is positive, it must open upward. If it is negative, it opens downward. And then for the horizontal parabola, if it is positive, it opens to the right. If it is negative, it opens to the left. So take note of that one. And lastly, take note as well that the length of the latus rectum is absolute value of 4p. So as you can see, the p in the equation plays a huge role. So don't forget that. So with that out of the way, let us now deal with the examples. For our first example, our goal is to find the equation of the parabola with focus at the point 0, -2, and equation of directrix given by y equal to 2. In solving this one, my suggestion is that you first plot what you have into our graph. So we would have this thing out here. So from the given, we know that the focus is this, the directrix is this. So the focus would be located out here, and the directrix is a horizontal line since it is given by y equal to a constant. And once you have this, you can actually immediately obtain the vertex. Just recall that by definition, the vertex is a point that is on the parabola and is in line with the focus. So if it is in line with the focus, then you can expect that it would be something around here, right? But then again, it is a point at the parabola, and we know that from the definition of the parabola, the points on the parabola must have an equal distance from the directrix and from the focus, which means that out of the points possible out here, the vertex must lie out at the point 0, 0. Since if it lies out here, then its distance out here is 2, and its distance out here is 2, which follows the definition of the parabola. So this means that the vertex of our parabola is given by the point 0, 0. Then also from this graph, we can also immediately obtain its orientation. So take note that when the directrix is a horizontal line, you expect that the parabola must be oriented vertically, either like this or like this. But we know that its concave part must contain the focus, which means that the vertical parabola cannot look like this since it won't contain the focus and it would intersect the directrix. So you expect that the parabola must look something like this. So that would play a role in how our equation would look like. So far, from the vertex, we know that we have the equation given by oriented vertically, so x minus 0 squared equal to 4p times y minus 0. Here, we obtain that from the vertex, and then the squared variable is x since the parabola is oriented vertically. So this time, our only problem is determining the p out here. But take note that the p, again, like I mentioned earlier, it plays a role in how you obtain the focus and directrix. It is what you add from the vertex to obtain the focus and kinda to obtain the directrix as well, which means that it's like the distance that you add from the vertex, which we know in this case to obtain the focus we add 2. To be specific, we subtract 2 in its y coordinate, and similarly its distance from the directrix is 2, which means that p out here must be 2. But since our parabola is opening downward, this must be negative. That means the equation of the parabola is given by quantity x minus 0 squared equal to 4 times negative 2, as we obtained earlier, times y minus 0. So that gives the equation of the parabola in this problem. So as you can see, there are certain things that are important for you to understand in order to answer this problem. Let's now move on to our second and final example. In this problem, our goal is to find the equation of the parabola which opens to the right. So if it is opening to the right, you kind of expect that the parabola must be oriented horizontally and with endpoints of latus rectum at the points negative 8,2 and negative 8,6. So let's first state what we have. From the given, we have the following. The parabola is oriented horizontally and opens to the right, and the endpoints of the latus rectum are negative 8,6 and negative 8. So first, since it is oriented horizontally, you expect that the equation must look something like y minus k squared equal to 4p times x minus h. The important thing to note here is that the squared variable is the y. So take note of this equation. We will be using this later on. And also, since it is opening to the right, we expect that the p there must be positive or greater than 0. The reason being is just recall from the table earlier. Next, since we know that the endpoints of the latus rectum are given by this, then we can conclude that the absolute value of 4p is equal to 4, and so p is equal to 1. And why is that? Recall from the remark earlier that the absolute value of 4p out here represents the length of the latus rectum. So take note that absolute value of 4p is the length of the latus rectum. And for this one, these are the endpoints of the latus rectum, which means that you can use the distance formula to obtain its length, and you'll see that it will be 4. So this means that this must be equal to 4. Or if you don't believe that, you can just view it in a sketch. Let's see, we have this thing out here. See, this is negative 8, this is 2, and this is 6. So our points would lie somewhere around here and out here. Since this one is 2 and this one is 6, you expect that this distance must be 6 minus 2 or 4. That's why it's 4. And then once you have this, solving for p out here, you can either obtain p equal to 1 or p equal to negative 1. But since we obtained earlier that p is positive, we conclude that it must be p equal to 1. So we now have the p from the formula. What we have so far is this equation out here. Our only problem is determining what h and k is. And can you guess how we will obtain this from what we have? Well, we can use these points, since these points are points on our parabola. And why is that? So just recall that from the definition, the latus rectum is the line segment wherein its endpoints are on our parabola. And once you have that, take note that if these two are points on our parabola, then that means that if we plug this into our equation, it must hold. Or in other words, at negative 8,2, this equation must be true, and at negative 8,6, this equation must be true. Basically, we just plug in negative 8,2 out here and negative 8,6 out here. And then once you have that, observe that these two are just two equations with two unknowns. And from system of equations, we know that we can obtain a unique value out here. So you can verify that solving for h and k, we will obtain h equal to 4 and k equal to 9. So if you don't know how you will start with that one, the best way to do that is observe that these two are equal, this part out here. Then that means that these two must be equal as well. So we will have here 2 minus h squared equal to 6 minus h squared. And then this one is easy to solve. I don't know how you solve this. You can use cases, but personally, what I do is I move this to the other side to obtain 2 minus h squared minus 6 minus h squared equal to 0. And then this one is difference of two squares. So you can write this one as 2 minus h minus 6 minus h times 2 minus h plus 6 minus h equal to 0. And then from there, you can just easily solve this one. You can see that this thing will just be constant, so it's just up to this to determine the value of h. Then once you have h, you just plug it into either this or this to obtain k. Given that, we can now conclude that the equation of the parabola is given by the equation quantity y minus 4 squared equal to 4 times quantity x plus 9. Basically, we just plug this in out here. And that answers the given problem. We have obtained an equation of a parabola which opens to the right and with endpoints of the latus rectum given by these 2 points. So just one final word out here. Again, it would be really helpful if you could help me provide better math content to you by answering the Google form in the description down below or the comment section down below. So it's just 3 questions asking you what you liked about it, what you disliked about it, and any suggestions, any particular topic that you want to cover to be able to help you in your journey in learning math. If that's too hassle for you, you can just go to the comment section down below and write out your feedback, and I'll be happy to read those. So yeah, that's it. I hope you enjoyed this one, and yeah, have a nice day.